Magnetism is a fundamental force of nature that exists between certain materials, particularly iron, nickel, and cobalt, but also other materials such as some types of alloys and rare earth elements. Magnetism is caused by the movement of electric charges, specifically the movement of electrons within atoms. There are two types of magnetic poles, north and south, which attract opposite poles and repel like poles. When two magnets are brought near each other, the north pole of one magnet will attract the south pole of the other magnet and vice versa. Magnetic fields are the areas around a magnet where its force can be felt. These fields are strongest at the poles of the magnet and weaken as you move away from them. The strength of a magnetic field is measured in units called teslas. Magnetic fields can be created in a few different ways. One way is by placing a magnetic material, like a piece of iron, inside a coil of wire with an electric current running through it. This is called an electromagnet, and the strength of the magnetic field can be adjusted by changing the amount of electric current in the wire. Another way to create a magnetic field is through the motion of charged particles, such as the electrons in an atom. When electrons move, they create a magnetic field around them. This is why some materials, like iron, are naturally magnetic. Magnetism has many practical applications. For example, magnetic materials are used to construct motors, generators, and transformers. They are also used in magnetic data storage devices like hard drives and credit card strips. One important concept in magnetism is magnetic induction. This refers to the process of creating a magnetic field in a material by exposing it to a magnetic field from another source. This can be done with both permanent magnets and electromagnets. When a magnetic field is applied to a material, it can cause the magnetic domains within the material to align. Magnetic domains are regions within a material where the magnetic fields of individual atoms are aligned. When these domains are aligned, the material can become magnetized. The strength of a magnetic field can also be affected by the shape of the magnet. For example, a magnet that is shaped like a horseshoe will have a stronger magnetic field than a bar magnet of the same size, because the magnetic field lines are concentrated between the poles of the horseshoe. Another important concept in magnetism is magnetic flux. Magnetic flux refers to the amount of magnetic field that passes through a given area. It is measured in units of Webers, WB, or Tesla square meters, trademark 2. The strength of a magnetic field is proportional to the amount of magnetic flux passing through a given area. This relationship is described by Faraday's law of induction, which states that a change in magnetic flux through a loop of wire will induce an electromotive force, EMF, in the wire. Magnetism also plays a role in the Earth's magnetic field, which is generated by the motion of molten iron in the Earth's core. This magnetic field is important for protecting the Earth from harmful solar radiation. One interesting phenomenon related to magnetism is diamagnetism. Diamagnetic materials are materials that have no net magnetic moment, meaning they are not attracted to a magnet. When diamagnetic material is placed in a magnetic field, it will experience a weak repulsive force. Another interesting phenomenon is paramagnetism. Paramagnetic materials are materials that have a net magnetic moment, meaning they are attracted to a magnet. When a paramagnetic material is placed in a magnetic field, it will experience a weak attractive force. Ferromagnetism is another important concept in magnetism. Ferromagnetic materials are materials that are strongly attracted to a magnet and can be magnetized. Iron, cobalt, and nickel are all examples of ferromagnetic materials. When a ferromagnetic material is placed in a magnetic field, it can become magnetized and retain its magnetization even after the magnetic field is removed. Magnetic resonance imaging, MRI, is a medical imaging technique that uses strong magnetic fields and radio waves to generate images of the body. MRI is particularly useful for imaging soft tissue, such as the brain and internal organs. Some interesting facts about magnetism. Magnetism can also be used to generate electricity. This is the basis for how generators work. When a magnet is moved past a wire coil, it creates a changing magnetic field, which in turn induces an electric current in the coil. This phenomenon is known as electromagnetic induction. Magnetic levitation, or maglev, is a technology that uses magnetism to lift and propel objects without physical contact. This is used in some high-speed trains, where the train is lifted and propelled by magnetic fields created by electromagnets along the track. The strength of a magnetic field can be measured using a device called a magnetometer. Magnetometers are used in various applications, including geological exploration, navigation, and detecting metal objects. The strength of a magnetic field decreases with distance from the source, following an inverse square law. This means that if you double the distance from a magnet, the strength of the magnetic field will decrease by a factor of 4. The north magnetic pole and the south magnetic pole are not fixed in place. They can move slowly over time, and sometimes even switch places. This phenomenon is known as a geomagnetic reversal. In conclusion, magnetism is a fascinating and important topic in physics with a wide range of practical applications. I hope this information has helped increase your understanding of magnetism. If you have any further questions, please don't hesitate to ask.